Hello there and welcome to Help Grow Academy. In today's class, we'll be solving over 10 most repeated Post-UTME questions on physics. Don't forget to hit the like button, subscribe to this channel and leave a comment in the comment section. The first question we have for today says, a car accelerates uniformly from rest to a speed of 20 meters per second in 10 seconds. What is the acceleration? Option A says 1 meters per second squared. Option B, 2 meters per second squared. Option C, 4 meters per second squared. And the fourth option, 5 meters per second squared. Solution. Recall that acceleration simply means the rate of change of velocity. Acceleration simply means the rate of change of velocity, and it is expressed mathematically as A is equal to V minus U over T, where A here stands for acceleration. A is equal to the acceleration. V here is equal to the final velocity. We have V to be the final velocity. U here is known as the initial velocity. T here stands for time. Now, having known this, let's write out the given parameters from the question. From the question, it says a car accelerates uniformly from rest to a speed of 20 meters per second. Now, they have given us the final velocity. When you see it into a speed of 20 meters per second, they gave us final velocity V to be 20 meters per second. They say in 10 seconds, so they gave us time. Time is what? 10 seconds. They say what is the acceleration? So we don't know the A. They say we should find A, acceleration. But recall, it says a car accelerates uniformly from rest. Mark this word, rest. When a car accelerates uniformly from rest, it therefore means that the initial velocity U is equal to 0. Now, if we substitute these values into this equation, we have A is equal to V minus U. Instead of writing V, we replace it with 20. 20 minus 0 divided by the time, which is T, 10. 20 minus 0 will give us 20 divided by 10. 20 divided by 10 is equal to what? 2. Therefore, the acceleration is given as 2 meters per second square. This is the final answer. From our options, we can deduce that the correct answer to this question is option B with 2 meters per second square. The work done in lifting a 10 kg object to a height of 5 meters is dash. The work done in lifting a 10 kg object to a height of 5 meters is dash. They gave us acceleration due to gravity to be 10 meters per second squared. Option A here says 50 joules. Option B, 100 joules. Option C, 500 joules. And D, 1000 joules. Solution. Recall that work done against gravity is given by this formula. Work done against gravity is given by the formula W, which is work done, is equal to mgh, where m stands for the mass, g stands for acceleration due to gravity, and h stands for the height. From this question, we are given the mass, right? They said a work done is done in lifting a 10 kg object. So they gave us mass. Mass is equal to 10 kg to a height of 5 meters. They also give us height, which is h, to be what? H is 5 meters. From the question, they gave us acceleration to gravity, g, to be 10 meters per second squared. So we have g is equal to 10 meters per second squared. Let's substitute these values into this equation. We have that w is equal to mgh. So instead of writing m, we replace it for 10 kg times, instead of writing g, we replace it with this value, 10 meters per second squared, times, instead of writing h here, we replace it with the value for h here, which is 5 meters. This will give us 10 times 10 will give us 100. 100 times 5 will give us 500. Don't forget, the units for work done is measured in joules. The unit for work done is joules. Therefore, work done is equal to 500 joules. This is our final answer. Now from this option, the correct option is option C, 500 joules, which is this. Question 3 says, if the force acting on an area of 2 meters squared is 100 newtons, what is the pressure? If the force acting on an area of 2 meters squared is 100 newton, what is the pressure? Option A says 50 pascal. Option B, 100 pascal. Option C, 200 pascal. D, we have 400 pascal. So let's solve. Solution. What is pressure? Pressure can be defined as the force acting per unit area. Pressure is the force acting per unit area. So we have pressure. Mathematically, it is expressed as P is equal to F over A, where P here stands for the force and A here stands for area. From the question, it says if the force acting on an area of 2 meters squared, so we have area. From the question, they gave us area is equal to 2 meters squared. They gave us the force is acting on an area of 2 meters squared is 100 newtons. So they gave us force to be 100 newtons. They say what is the pressure? P, we don't know P. They say we should find P from the question. So we have P is equal to F over A. Instead of writing F, we replace it with this value, 100 divided by A. The value for A is what? 2. This will give us 100 divided by 2 will give us 50. The unit for pressure is pascal. Therefore, pressure, the pressure P is equal to 50 pascal. This is our final answer. So from the options, we have option A to be correct, 50 pascal. Question 5 says, what is the wavelength of a wave with speed 340 meters per second and frequency 170 Hz? Option A says 1 meter. Option B, 2 meters. C, we have 0.5 meters, and D, we have 4 meters. Now let's solve this. We are going to solve this equation using the wavelength equation, where we are going to solve this using the wave equation. So we have, using the wave equation, we have V is equal to F lambda, where V here is the wave velocity, F is the frequency, and lambda here is the wavelength. So we have V is equal to the wave speed or velocity, let's say wave speed. F here is the frequency, and lambda is given as the wave length. Now from the question, we were given, they say, what is the wavelength of a wave with speed 340 meters per second? So they gave us V, the wave speed, to be 340 meters per second. They say, and frequency 170 hertz. So they gave us frequency F to be 170 hertz. They say calculate the what? The wavelength. What is the wavelength? So wavelength, lambda, we don't know. From this equation, if we make lambda the subset of formula, we divide both sides by the coefficient of lambda, which is F. If we divide, which is V is equal to F lambda. When we divide both sides by the coefficient of lambda, we have this. This will take away this. We are left with lambda is equal to V over F. If we substitute these values into this equation, we have V is what? 340 meters per second. So we have 340 meters per second, all divided by hertz. This is 340 divided by the frequency, which is 170 hertz. So frequency is what? 170. 340 divided by 170, it will give you 2. The unit for wavelength is what? Meters per second. Therefore, the wavelength is 2 meters. From the question now, we have the correct option to be option B with 2 meters. Question C says, what is the resistance of a conductor if a current of 2 amps flow through it when the potential difference is 12 volts? What is the resistance of a conductor if a current of 2 amps flows through it when the potential difference is 12 volts? Option A says 2 ohms. Option B says 4 ohms. Option C, 6 ohms. And option D, 24 ohms. Now recall from Ohm's law that V is equal to IR, right? Where V here is the voltage, I is the current, and R is the resistance. So we have V is equal to the voltage I here for the current, the voltage measured in volts, current measured in amperes, and R here is for the resistor or resistance. Let's say resistance measured in ohms. From the question, they said, what is the resistance of the conductor? So the resistance, we don't know it. If a current of 2 amperes, they gave us current I to be what? 2 amps. Flows through it when the potential difference is 12 volts. When you see the word potential difference, it is the same thing as the voltage. Now the potential difference V is 12 volts. Now from this question, we have V is equal to IR. We have the value for V and we have the value for I, but we don't know R. So what we need to do is to make R the subset of formula. If we do that, we divide both sides by the value attached to R, which is I. We have V is equal to IR. When we divide both sides by the value attached to R, which is I, this will cancel this. We're left with R. This will give us R is equal to what? V over I. V over I. Now from this equation, if we substitute these values into this equation, we have R is equal to, instead of writing V, we replace it with what? 12 over I. I from the question is giving us what? 2 amperes. R is equal to 12 divided by 2 will give us what? 6. Therefore, the resistance is 6 ohms. Don't forget the unit for resistance is what? Ohms. So this, from this option here, the correct option is option C. 6. Question 7 says, which of the following material is not magnetic? Which of the following material is not magnetic? Option A says iron, option B says nickel, option C says copper, and option D says cobalt. Now, from these options here, they have what they call ferromagnetic materials. These materials are easily attracted by a magnet. Examples of ferromagnetic materials, we have iron is a ferromagnetic material. Nickel is also a ferromagnetic material. Cobalt here is also what? A ferromagnetic material. But copper is not a ferromagnetic material. It is a non-magnetic conductor. It does not attract object to itself. So the correct option here is option C, copper. Because copper, like I said here, is a non-magnetic conductor. So the correct option here is option C, copper. Question 8 says, the image formed by a plane mirror is dash. The image formed by the plane mirror is A says real and inverted, B you have visual and upright, C real and upright, D magnified and real. Plane mirrors always form an upright visual image that is the same size as the object and literally inverted. So the correct option here is option B, because they form upright and visual image that is the same size as the object, but they are literally inverted. So the correct option here is option B, visual and upright. Now it says the energy of a photon is given by E is equal to HF. What does H represent? This is the kind of questions you see in your Post-UTME. What does H represent in this formula now? Option A says heat capacity, B says Planck's constant, C says wavelength, and D says specific heat. If you have followed me down to this point, you know that wavelength, this is not the formula. H here, from the previous question we saw, wavelength is denoted by what? By lambda. So this is out of it. This is out of the ball game. So C is wrong, specific heat is wrong, heat capacity is wrong. The correct answer here is the Planck's constant. The Planck constant is, from the equation there, the Planck's constant, H, is a fundamental constant in quantum mechanics. Is a constant given by 6.63 times 10 raised to the power minus 34 joules per second. This is the value for H, the Planck's constant. So the correct answer here is option B, the Planck's constant. Question 10 says, the SI unit for power is dash. What is the SI unit for power? Option A says watts, B says newtons, C says joules, and D says what? Volts. Now recall that power is the rate at which work is done. So mathematically it is expressed as power is equal to work done over time. Work done here, the unit for work done is what? Joules. And the unit for time here is what? Seconds. Now this is the same thing as power is equal to joules per second. Now, having gotten power is equal to joules per second, note that 1 watt is equal to 1 joules per second. Since joules is equal to watts, like 1 watt is equal to 1 joules per second, we can say power is also measured in what? Watts. Not just joules per second. So the unit for power is what? Watt. Since 1 watt is equal to 1 joules per second. Therefore, the correct option here is option A. Power is equal to watts. Thank you guys for watching. Don't forget to hit the like button, subscribe to this channel, and leave a comment in the comment section. Till then, see you in our next video.